Hello, my name is Phillip Walker, and I am going to be providing a presentation on a project that I completed using CATIA v5, specifically with the Knowledgeware features, as well as the Knowledge Advisor workbench, which make use of preset variables, equations, and design tables to quickly change clustered CATIA models depending on various users' needs. This project was created as an assignment for an advanced CATIA workbenches course provided by the Everett Community College, which furthered the experiences I'd had with CATIA from previous college courses and from my direct industry use of the software as a structural analysis engineer with the Boeing Company. And I will quickly access the design table I set up for the coat hanger model that I was using to demonstrate that the coat hanger itself can be adjusted so that it can have a small number of rungs down to 2 up to a larger set of 5 with 3 and 4 rungs in between. Moving on to the PowerPoint presentation. As this PowerPoint presentation shows, the specific model that I chose to create was a variable coat hanger made of alpine fur that was meant to be a designer product for multiple outlets. As the second page indicates, the model could easily be adjusted to change the number of rungs on the coat hanger, the diameter of the attachment bolts, and the thickness of the base by accessing a convenient design table which collected preset data for coat hangers that represented supports for 2 to 5 coats. The relationships set up in the formula feature of the knowledge toolbar would then cause the coat hangers to grow and shrink accordingly to allow for sufficient edge margins of the bolts, which I quickly demonstrated in the actual model. Now, a full lug analysis might be desired if the model were to be made more economical while still maintaining structural capability at the edges, and similar analyses could be performed for the spacing between rungs and the distance from the edge rungs to the bolts. The third page shows images of the 4 models that were constructed in the design table, along with their recognizable product names. On the 4th page, we have a screenshot of the model specification tree, and highlighted here are the parameters and relations, including the design table, which I labeled hanger types and variables. The part body here in this screenshot is compressed for space. Down here, this part body is compressed for space on this screenshot, but it contains padded features for the hanger's base and rungs, with the rungs being repeated with a rectangular pattern, holes to the attachment bolts, and fillet specifications at the ends of the base. And of course I can quickly demonstrate that over in the model I made. Here's the part body with its material specification here, and here are padded features for the hanger base and the first rung, additional rungs with being made with a rectangular pattern, holes at the edges of the base, and then fillets at the edge of the base as well for space considerations and just aesthetic details. Back to the presentation really quickly. And we will summarize by saying that this project utilized several Knowledgeware functions, including parameters, formulas, and design tables, while also utilizing typical part design features for the setup of the model and Microsoft Excel for the associated design table. The total time spent on the project was 5 hours, as noted here, and I also noted the total time spent on the class up to that point.